All right, welcome to module number 1, Threat Mitigation through Identity Services, module number 1 of the SISAS course. In this module, we're basically going to focus on 3 primary objectives. We're going to take a look at how ICE or Identity Services fits into the overall architecture of your security posture. We know we talk a lot about this concept of defense in depth in network technology, making sure that we have multiple layers of protection and defense. Obviously, that's going to include the Cisco Identity Service Engine, which is basically Cisco's next generation platform that allows us to apply security policies, do some sort of compliance enforcement. We also incorporate infrastructure security in this component, which is going to include things like MACsec and TrustSec and so on. We'll talk about 802.1x, the extensible authentication protocol, and we're just going to basically just take a look at the secure access solution and see how that fits into the overall architecture. I know you, Andy, mentioned that you guys have already implemented this technology. Michael, are you guys working with ICE today?
No, Campus does, but we don't.
Campus does, but you don't. Okay. So, this platform integration works with your wireless environment, with your controllers, your firewalls for edge perimeter security and mobility like VPN access, data center, and so on. So that's really what we're going to focus on in this first module, is just really take a look at, we got 3 separate lessons in here. We'll take a look at, all the different components of identity services, what that entails, and so on. So our first lesson is identity services. Traditionally, what we've always considered with regard to identity services is protecting the perimeter through a VPN solution, where we're actually identifying users that are connecting through VPN using traditional methods. And we talk about some of those traditional techniques to managing secure access, but a lot of those tools that we had in the past were really kind of separate, disparate tools that allowed us to manage security. We had maybe some 802.1x for extensible authentication at the edge of the network, and we had access control lists and VLANs and filtering and whatnot applied throughout the network, but it really wasn't integrated together to provide that kind of integrated solution that allowed us to manage things more easily and kind of throughout the entire network. So what we're going to talk about is really incorporating intelligence in this particular suite of protocols and suite of processes that we're using for authenticating users to access the network, whether it's VPN users or users that are just internally connecting to the network and so on. All right, we know that Cisco has a whole bunch of products and services that are available to provide these services, but what we're going to look at in this lesson is what is a secure access solution? How do we identify all of the key components, like, for example, authentication, authorization, and accounting, kind of our traditional AAA approach to security, making sure that we are able to authenticate the users. Once they're authenticated, what are they allowed to do? And then also making sure that we're logging those transactions and making sure that we're identifying or maintaining information about what the person's doing while they're doing it, right? Typically, in the past, we've always used Radius or TACX to provide those services, but now we're integrating those, and we use a platform in the past called Cisco Secure ACS, Access Control Server, but now it's integrated into Cisco Identity Services Engine. So in this lesson, just a real quick bullet point list, we're going to talk about the modular network architecture, describe Cisco's secure access solution. We'll take a look at the secure access portfolio in this lesson as well. What is authentication? What is authorization? What is accounting as part of that AAA architecture? We'll take a look at a concept a term that you may or may not be familiar with, but we see it quite often in the realm of identity services, which is called COA, change of authorization. We'll take a look at the identity sources, and then we'll also take a look at Radius and TACX as a protocol as well. All right. Now, Cisco does have kind of a modular network architecture framework to provide what we call defense in depth. The idea here is that we're positioning different Cisco products that have a bunch of different functions or capabilities in the network, but they work together in a collaborative effort, exchanging information between them to provide all kinds of security components, right? You might have some sort of PCI compliance, data leak or data loss prevention, threat control components, threat control meaning identifying threat vectors and being able to employ or use countermeasures to protect against those different threat vectors. What are the kinds of physical devices that we have, like VPN components, monitoring components, firewalls, email filtering, and so on. And then the infrastructure, right? What we call NFP, which stands for Network Foundation Protection. We want to make sure that our routers, our switches, and our servers are protected because that's the foundation of our network. And if those components are not protected, then we may as well not have security in place at all. All right. Obviously, we have different building blocks here, what we call the modules of the network, the WAN edge, the branch module, e-commerce, teleworker, and so on, which may or may not all apply to your organization, but certainly we want to consider those components as part of our security architecture. We want to be able to see what's happening in the network. We want to be able to control what's happening in the network. So identify threats, monitor for threats, do some sort of event correlation if we're trying to identify the impact of a threat to our organization, harden our devices with standard baseline configurations and best practice security standards, isolate threats with these security measures, and then enforce policy, right? Sometimes we have a lot of different administrative controls that we implement in our environment, and we need to have policies to be able to enforce those administrative controls through either some sort of technical control or, although we don't do too much with physical controls with ICE, but certainly that could be a component as well. So really this whole diagram here just describes all of the different components that comprise this modular network architecture, right? And that's really what this diagram is showing you. It's delivered in the form of something called the design blueprint and security solutions, and you can go to Cisco.com and you can actually download recommended design blueprints, what we call Cisco validated designs or CVDs. It's basically a prescriptive design guidance to provide validated designs for implementing these different technologies. We have our interface points in our network, like the campus itself, the WAN edge, the branch, the data center. And so what these Cisco validated designs provide you is guidance basically on the technologies that you're going to implement in these different areas, like Cisco Unified Communications, if you're doing any kind of network virtualization, like I said, network foundation protection for routing and switching and so on, and what we do with those particular components. And you can, like I said, go out to Cisco.com and identify, they actually have publications that identify different design blueprints for those different technologies. We also have Cisco security solutions, what we call the security framework. Basically works, these are designed to work with the blueprints, giving you that foundation of industry security solutions that really address all of the industry security standards that you might see in different business sectors, like retail, financial, healthcare, and so on. Definitely something to take a look at. Like I said, on Cisco.com, you can find that information if you just search for Cisco validated designs or Cisco design blueprints. All right. What we're seeing on this slide here is really just the modular design that we just described in the previous section, based on the fact that different components of the network architecture have different security requirements, and will place different security pieces into those those different modules based on what our security needs are, right? What are the controls that we're going to implement? Obviously, we want to try and implement these things in some sort of high availability mode. We have the CIA triad that we're always concerned about protecting, right? Andy, you know all about that, being CISSP, right? We want to ensure confidentiality, we want to ensure integrity of the information, and we want to ensure availability of the data. Not just the applications in the network, but the endpoints and the network itself, right? What we see in this diagram is endpoint security, right? Today we have lots and lots of different types of endpoints, and it gets a little bit more complicated, especially if you allow like BYOD, where you can bring in tablets and smartphones and personal laptops and so on. So we have wired and wireless components. We have a lot more components in the network that provide a lot more intelligence. For example, your typical copy machine in the past wasn't essentially a computer, but nowadays it's actually a computer on the network that has lots and lots of capabilities of managing information on the network as well. That's something that you would normally not maybe take into account in the past. We know that these devices need to be secure. We're trying to protect our data from loss and theft, loss of privacy, loss of integrity, and so on. This could be directives that are, directives based on the environment that we're in. Maybe we're in a particular industry that has regulations that require that, or it could be simply just because we want to, operate in a best practice scenario. So we'll see throughout this whole course, right, the CCNP security, looking at context-aware devices. Obviously, this course focuses on the Identity Service Engine, but there are security components related to the wireless LAN controller. We're going to take a look at the Cisco AnyConnect Secure Mobility Client, which allows us to integrate security in wireless, but also for 802.1x and so on. We'll take a look at network security components, really kind of the fundamental piece of of security overall is protecting that foundation, making sure that we're not experiencing any kind of loss of service due to denial of service attack, theft of information, and so on. So we would have like an ASA 5500, maybe some virtual security gateways. That's what we talk about primarily in the other part of the course, is the CCNP Security Part 1. How do we integrate security into our ISRs? What are VPN components? How can we provide both infrastructure VPN securely as well as remote access VPN and so on? And what we're going to be covering in the second half of this course, SITCS, is content and application security, looking at email applications, web security, using the web security appliance, looking at intrusion prevention components and so on, and all of those services that get integrated into the ASA 5500 next generation firewall. And then how do we manage this overall architecture? It's much more complex. We have a whole bunch of components that are being used throughout this architecture. These components have to be able to communicate to each other. They have to be able to share information with each other. So we have things like CSM, Cisco Security Manager, Prime Infrastructure, and also Secure Access Control Systems. Although that's ACS is kind of going away. It's been integrated primarily into Cisco Identity Services Engine. All right. Overall, our goal is, we need to be able to identify who you are, right? And we do that through various authentication methods. What type of device you're connecting with. Traditionally, that hasn't always been a concern. We've mostly been primarily concerned with identifying essentially who you are. We didn't really look at what you were connecting with, but with the advent of BYOD, obviously that's a concern. We want to make sure we know what you're connecting with. Also, where you're accessing the network from. Are you using a small office or home office? Are you a corporate partner connected via an extranet? And then also, how are you connecting? When are you connecting? And so on. These are all concerns that we have with overall security. So all of this relates to something called the context of your communication. We have policies that drive security, right? what we tend to call in the information assurance world, we call this administrative controls, right? Where we define policies, acceptable use policies, BYOD policies, etc. We have some sort of device, in this case, ICE, right? That provides this centralized policy engine. There's different types of ICE nodes. We'll talk about those different nodes a little bit later on. And that ICE allows us to push down or configure dynamic policies, dynamic enforcement policies, and there's a monitoring and reporting component of that as well, right? Some of the dynamic policy and enforcement could be things like obviously implementing 802.1x, being able to identify what VLAN a client might belong to, doing some sort of flexible authentication with extensible authentication protocol, applying downloadable ACLs, security group access using security group tags, profiling devices, doing some sort of posture assessment, and if we do have external parties accessing our infrastructure, guest access and guest requirements as well. So we'll talk about all of that. Obviously, that's what this whole course is really all about, is identifying all those components. So what are the portfolio products that provide that? Obviously, the heart of the entire architecture is ICE, right? Identity Services Engine. This gives us our centralized management. We have our policy platform, context-aware access control, all the decisions that we're going to make based on whether somebody is connecting over the wired network or over a wireless network. It includes things like AAA, primarily through use of Radius and TACX, device posturing, device profiling, guest management features like single, individual guest access, like temporary guest access, or even contractor access for longer periods of time. And really just a central platform that gives us all of that enforcement, those enforcement options. And then at the policy enforcement points, where we're actually implementing the policy, we have all of our network components. It could be our switches, our context-aware switches, our context-aware routers, our context-aware firewalls, and so on. These are the devices that are going to allow us to enforce whatever policy that we're trying to employ. And then we have our supplicant components, right? Network Access Control Agent, NAC Web Agent, although these are pretty much going away and everything is really kind of rolling into what we call the Cisco AnyConnect Mobility Client, which is our 802.1x supplicant. It does a lot more than just 802.1x, but and we'll see that because we've got a bunch of labs that we're going to be doing as well as part of this course where you guys are going to be able to go through some different configurations. All right. Authentication, in a nutshell, who are you, right? And we talk about different authentication methods. Typically or traditionally, it's always been about identifying an individual based on credentials, right? Username and password, but authentication extends beyond that today. We have the ability to identify through biometrics, something you are, common access cards, something you have, or tokens, something you have as well, or maybe something like a password or a PIN, right? But the bottom line is authentication allows us to identify a user. Now, what's changed over the years, over the past several years, is now we're not only trying to identify the user, but we're also trying to identify the endpoint, the actual individual that's, or the actual physical device that's connecting to the network. Really, the whole idea, though, here is that who are you, right? And you can provide those that identification in several different ways. 802.1x is what we're going to focus on in this class. It's going to require some sort of agent. Typically, it can be built into the operating system. And there are many, many different supplicants that are built into the operating system. But we also look at Cisco AnyConnect and how AnyConnect fits into this realm, right? Cisco defines that as a premium supplicant, which has a whole bunch of other features built into it besides just 802.1x. What if we don't have a supplicant, right? We're using some sort of device that doesn't either have the AnyConnect client or doesn't have some sort of embedded supplicant. Well, we can also do things like web authentication. Web authentication provides a way for us to authenticate users through a web page that, for devices that don't necessarily have that 802.1x supplicant. So this is really the first type of authentication option that I have is 802.1x. Web authentication could be used, of course, if I don't have a client that supports any kind of 802.1x supplicant. And then we also have Mac authentication bypass, right? This could be typically used for a scenario where you have like a printer or some device that doesn't support either, doesn't have a GUI or user interface that allows us to do web authentication, or it doesn't have an 802.1x supplicant. So we have a database of MAC addresses that simply allow access based on that database of MAC addresses. In the book, they recognize that MAC authentication bypass is not MAC authentication. We're bypassing authentication altogether based on the MAC address that's installed on that particular device. So actually, it's not really authentication at all. Unlike where you might have a secondary authentication process that's derived from the MAC address of the component or the device that's connecting. All right. We can also do VPN authentication as well, where we're trying to authenticate VPN users, either through SSL VPN solutions or through IPsec VPN. And this platform allows us to integrate those components as well. All right. Once you're authenticated, the next step is then to identify what you're allowed to actually do. That's the authorization. Authorization is where can you gain access to, what resources can you gain access to, what network resources are you allowed to communicate to, and so on. It's not just simply a matter of identifying that you can access this file or that file, but where are you allowed to communicate in the network as a whole. All right. Now, traditionally, once we've authenticated a user, this was a pretty static type of configuration. Right? A device was connected to a wireless SSID, and we had some sort of static configuration on that wireless network that allowed specific types of communication. So the authorization was simply applied to the SSID through a VLAN configuration, or it was applied to a physical port if it's a physical device through a static VLAN configuration, and so on. But now with this additional policy enforcement platform with Identity Services Engine, we can actually dynamically create this authorization process instead of statically providing this authorization process, right? ACLs, which we typically would use to secure access, it's a stateless packet filter essentially, where we're filtering based on IP address, port number, protocol, application, and so on. Well, we now have this ability to do something called a downloadable ACL, where we can actually essentially apply access control lists to our switch based on the actual authentication of the individual dynamically instead of statically, or with a wireless LAN controller, some sort of named ACL. All right. Is it a contractor? Is it an employee? Is there an IP address change that's required? In other words, we're going to put them into a different VLAN, and so on. All right. So these are per session access control lists that we install on the switch, or named ACLs, like I said, on the wireless LAN controller, or dynamic VLAN assignments is also a big step too, right? Instead of actually statically configuring a VLAN for a particular port, are we going to dynamically create a VLAN? So maybe we've identified, for example, that a device doesn't meet our policy with regard to the appropriate software, patches, etc. We might put them into a remediation VLAN. Or if you're simply a guest, we'll put you into a guest VLAN, or we'll put you into an employee VLAN, right? Obviously in this case, because we're just putting it into a VLAN, we're assuming that we've already have different security components applied to that particular VLAN. So we're not necessarily concerned about applying individual access rights to those users. We can do a combination of these as well, right? Downloadable ACLs, named ACLs, and then also implementing VLAN control. All right. The final piece is implementing what we call Cisco TrustSec, where we actually implement what we call SGA, Security Group Access. We can implement Security Group Access ACLs, apply some sort of SGA-based access control. So we keep our logical design the same at the access layer, but we apply policies and services or allow policies and services to be applied based on different business requirements for individuals connecting to the network at different points in the network. All right, so lots and lots of options there. We're going to go into in depth in all of these different technologies and how ICE can help us with all these different technologies a little bit later on. Finally, what we want to make sure of is that we're able to identify what you're doing, right? We've already identified who you are. We've already identified what you're allowed to do. The last step is accounting, which is basically what have you been doing or what are you doing while you're accessing the network. Typically, this is going to be a component that's necessary if we're trying to identify, more importantly, breaches in the network. We want to be able to account for what's happening in the network. First of all, we want to be able to identify whether or not our policies are being met, whether or not the controls that we have in place are adequate to and align with whatever policy that we're trying to implement. All right. So accounting allows us to essentially identify that. We're going to track the services that the users are accessing, the amount of network resources that they're consuming on the network from a perspective of bandwidth and utilization. And these accounting records contain what we call AV pairs, and those get stored on the security server. And then we can take some sort of third-party application, event correlation tool, or whatever it might be, whether it's for client billing or just for security assessments. Maybe we have a process involved for applying different security assessments throughout the life cycle of the user's ability to access the network and so on. ICE obviously has AAA accounting components built into it, and it identifies different accounting components based on the active session in ICE. Obviously, authentication and authorization provides information about the session start, who's connecting, how are they connecting, and so on. But it doesn't necessarily identify when the session gets terminated, and that's where accounting comes into play as well. We want to be able to identify when a session gets terminated as well. We need to know about the session itself, what are the statistics for that particular session, and again, we're trying to identify whether or not a particular breach has occurred or whether our policies are being met and so on. All right. Change of authorization, what we call COA, is a standard term that we see now with Identity Services Engine. Pretty much any kind of security posture that we apply, but ideally it applies to ICE because ICE has the ability to dynamically change the level of authorization for an individual component based on its present condition, right? Maybe we've decided that we want to go through some sort of remediation on the device itself, but once that remediation is complete, we want to change their level of authorization because they now meet the requirements that we've outlined in the beginning for them to connect to the enterprise. Obviously, with traditional Radius, Radius includes your basic AAA functionality, but there was no mechanism in Radius to dynamically return the client, tell the client basically that there is a change in their authorization policy and they can now go back and access different resources or different components, right? Radius did incorporate the use of change of authorization. That was defined in RFC 5176, and just to incorporate this capability, right? The AAA framework uses various different types of change of authorization messages. to essentially identify what has changed from the subscriber perspective, to allow them to either terminate a particular service that they might have access to, create an additional service that they need access to, or modify an existing service, right? After successful authentication, we know that in traditional Radius, you always had some basic access that was provided with that authentication process. And ICE can go through and take a look at, once you've authenticated, put you into some sort of kind of secondary zone where we can do another screening, and we can look at the posture of the device. Is the device in compliance, or is it non-compliant to what our policies are? And the change of authorization will be based on that. If you're in compliance, we'll take you out of this kind of quasi-secure area and put you into whatever area you need to access network resources. If you're not in compliance, then we're going to go ahead and reduce your privileges and then put you in some sort of remediation process or remediation VLAN or whatever it might be. All right. And this can be done by changing the VLAN that the client belongs to. It can be done by applying a different downloadable ACL and so on. A change of authorization can also be used with WebAuth. WebAuth oftentimes, and we'll see this as we go through some of our other discussions in the future, but WebAuth is oftentimes used as some sort of fallback authentication method for clients that for some reason they can't process the 802.1x configuration, or we can't push out policies to that device or something like that. So when we fall back to this web authentication process, the client's going to be presented with a web portal. We're going to issue a change of authorization. The ICE is going to issue a change of authorization to update the policy. And on the network access device, what we call a NAD, NAD, to whatever the appropriate context is for that particular client, right? Based on their particular authentication. The thing that we talk about with ICE, I mean, it's just a massively complex platform because it incorporates all of these different options and components. It can be a little bit daunting trying to identify what components you're going to configure, how do these components interact with each other, and of course making sure that there's no weaknesses in whatever implementation that you've decided to do. So that's why essentially we have an entire course on ICE, because it is such a robust platform, and it's really central to implementing all of the different security components that we want to implement in our enterprise. So we will see that as we go through the rest of this course. This is just kind of the introduction right now. What are some of the different identity sources that exist? As you can see here, we have basically four different components that incorporate the use of identifying endpoints and so on. We've got the user itself, which is running some sort of supplicant, what we call a supplicant that allows them to communicate with 802.1x. And then we have our network access devices, which is our wireless LAN controller or a catalyst switch. We have our policy engine, right, which has built into it Radius and TACX. So technically that's considered our authentication server. And then on the back end, we might have some integration with Active Directory or LDAP and so on to incorporate, single sign-on scenarios or ease of management of user credentials based on, specific credentials for an individual device, right? Rather than having different repositories for different types of authentication points, right? So when it comes down to it, really there's three major components to this whole authentication, authorization, and accounting component. The supplicant, the authentication, the authenticator, which is what our network access devices are, and then finally the authentication server on the back end, right? Now, ICE does have the ability to incorporate internal identity sources, right? You can actually have usernames and passwords and other authentication components built right into ICE. But ICE also has the capability of communicating to external identity sources as well. Primarily Active Directory, LDAP, but not just limited to that. And we're going to see what some of those options are later on, what different types of platforms ICE can integrate with. For example, a token server, if we're going to do some sort of RSA. Well, RSA is an example, but we could use several different types of token platforms. But where we're trying to identify based on something you have, and then also various credentials that are time-based or physically, something you have to physically have, like a token, a USB token, or something like that. All right. So Radius, obviously, remote access dial-up identification service. Radius provides us user service. Excuse me. Radius provides a standards-based protocol to facilitate all these different AAA functions. It uses these things called AV pairs to carry AAA information between the Radius client and the Radius server. And it is built in to the ICE platform. The AV pairs, they're called attribute value pairs. That's what AV stands for. And there's a bunch of them, right? I mean, hundreds of them. Well, not hundreds. I mean, a little bit less than 100, I think. I think there's probably about 60 or so. I can't remember how many there are specifically, but username would be example of an AV pair. That would be a value of 1, a string value. User password is AV2, which is a string value. If I'm doing CHAP, challenge authentication, that's AV3, and so on. And you guys are not going to have to know the different AV pairs that are required, but it is a standard approach to providing this, the passing of different attributes back and forth between, Radius and the component, right? ACS, for example, which is where this was integrated into originally. For the remote access dial-in user service, Radius, use these AV pairs, which contained all of the different components. Remember, Radius is an open standard protocol, so that we could support different authentication from different vendors. All right, and ICE has incorporated this in its configuration as well. I mean, TACX also uses attribute value pairs, and they have several different attribute value pairs as well. Address pool, callback, I can't remember all of them, but the ACL components, IP address would be a good example. Different prompts that are processed through TACX and so on. So there are. We could go into hours and hours and hours of discussion on the different AV pairs, but I wanted to describe essentially what those AV pairs represented. All right. So we use these AV pairs to carry our AAA information between the Radius client and the Radius server. There's a standard set of Radius attributes, and they're predefined. We also have extensible vendor attributes, attributes that are available as well. So there might be vendor-specific attributes or VSAs that apply to individual vendors as well. ICE uses dictionaries to organize the different AV pairs. It has a built-in system-defined dictionary for the IETF standard set of AV pairs, as well as some of the vendor-specific attribute dictionaries that Cisco provides for that other vendors might not support. We can also create what we call user-defined dictionaries if we want to incorporate other vendors' capabilities as well. Remember, the supplicants in this case might require specific types of attributes to process information. All right. Radius is a protocol that's based on UDP, and you can remember that because Radius has a U in it, whereas TACX is based on TCP. TCP port 49 to be exact, but Radius uses UDP ports 1812 for authentication, 1813 for accounting. Those were the standard ports that were defined in RFC 2865, and I think 2866 as well. But there are some legacy ports as well, 1645 for authentication and 1646 for accounting as well. One of the things that Radius differs from TACX in is that Radius combines the authentication and authorization component. So once you've authenticated, you're going to get your entire authorization profile in one, basically, confirmation, right? Whereas TACX tends to authenticate individual transactions rather than authenticating at once. TACX will authenticate individual transactions. It's not really important that you know that for this class necessarily, but it is kind of interesting. So we get an access accept packet that gets sent by the Radius server. That's going to include all of the authorization details for that particular client. So it's good in a sense that it's more efficient, but it's bad in a sense that it doesn't provide us the ability to decouple the authentication and the authorization piece, right? And there may be some instances where decoupling those components could be useful. All right. Sorry about that. We jumped off to the wrong page there. But another component that's built into Cisco ICE, which was also incorporated into the access control server, is TACX. TACX is the Terminal Access Control System. And it was actually a protocol that goes back way back into the early 80s. I think it was first developed in 1984. And it was used primarily as an authentication server, primarily for Unix networks. And then we saw what we call TACX that came out. That was a proprietary extension of TACX. That was developed in the 1990s, I believe in 1990 actually. It was supposed to be backwards compatible with the original protocol, but now Cisco wanted to incorporate these TACX components to allow remote access with an authentication server and to see if somebody has access to the network and so on. And then finally we come up with what we see today, which is the Terminal Access Control System Plus, or TACX Plus, developed by Cisco, released as a standard again in 1993, obviously derived from TACX, and really it's a protocol that incorporates authentication, authorization, accounting, but you can see in the case of this particular diagram here that the authorization, right, once we've authenticated, the authorization components are individual, right? Now this is accounting and this is authorization, but every single transaction that is run in a TACX scenario is based on, or is individually authorized, all right? Obviously, we know that TACX and Radius, TACX Plus, excuse me, and Radius have replaced the older versions. TACX Plus is not compatible at all with the original TACX or XTACX. TACX Plus uses TCP. Again, easy to remember because TACX has a T in it, doesn't have a U, whereas Radius has a U in it, so you can remember Radius uses UDP and TACX uses TCP based on that. It is an authentication, authorization, and accounting architecture, but it is a connection-oriented protocol. All right, we don't have to implement transmissions controls because it is built on top of TCP. Radius, on the other hand, does not have to detect doesn't have built into it the different detect and correct transmission errors. For dealing with things like packet loss, timeouts, and so on. So Radius is a connectionless protocol because it sits on top of UDP. One of the biggest differences, though, is that Radius only encrypts the user's password going from the Radius client to the Radius server. All the other information in Radius, like username, authorization, accounting, all that's going to be transmitted in clear text. So it is definitely vulnerable to different types of attacks, whereas TACX, on the other hand, encrypts all the information, username, authorization, accounting, and password, and so on. All right. So we don't need to necessarily get into the specifics of the protocol. I just thought I'd give you guys a little bit of history about the protocol itself. It is interesting. Most people assume that TACX has always been a Cisco proprietary protocol, but it was actually developed as an open standard and then adopted by Cisco to meet the needs of whatever they were trying to accomplish. All right. All right. So that is lesson number 1. All right. In this lesson, we talked about Cisco Secure Access Solutions and how that allows us to mitigate different security risks, looking at the framework and the different components and the different platforms that are available. We talked about the central element of this entire architecture is the Cisco Identity Services Engine. Obviously, we're going to do a deep dive into those components a little bit later on. What is authentication? How do we identify an endpoint or a user? What is authorization? What are you allowed to do? What kind of access control are we applying to that particular individual that's been authenticated? And then finally, accounting. Being able to identify different components of the session, the duration of the connection, different parameters of the connection, and so on. All right, so that's lesson number 1. In lesson number 2, which is part of this module as well, we are going to take a look at 802.1x and the extensible authentication protocol. It's a big lesson, right? There's a lot to talk about with 802.1x. What is 802.1x? What are the different deployment options for 802.1x? What is monitor mode versus low impact, and so on. So we'll talk about all that in the next lesson. We'll see you guys there in a little bit.